Welcome to ASOC Tutorials India program, a program to learn amateur radio in India. And today you are watching part 2 of Super Heterodyne Receiver. Before I go through continuous sessions, just I want to say you just try to recap, remember previous session I have explained. You must have remembered all three previous sessions shown on your screen. It is very important because I am continue here. And just try to remember receiver characteristics I have explained in previous sessions. Sensitivity, selectivity, fidelity, of course stability also. Same way double spotting, also called adjacent channel selectivity, its behave and work. And now I am coming on other stages. Automatic gain control, also called AGC, automatic volume control, also called AVC, Squelch circuit, signal to noise ratio, just I am going to repeat it, VFO, variable frequency oscillator, same way BFO, beat frequency oscillator. Just first I am coming to the term AGC and AVC. Try to remember the output volume variation of a receiver may be radio or TV, often results from variation in the input signal strength. Signal may be vary and the result output signal is also vary. These changes in input signal strength occur when we change stations or when we experience fading because of changing in atmospheric conditions. The function of AGC, or I can say AVC, is to limit unwanted variation in the output of the receiver caused by variation in strength of the receiver's signal inputs. A receiver without AGC or AVC would require continued manual readjustment time to time to compensate for received signal changes so that it could maintain a constant output level. Now come back to the block diagram of radio receiver. And in block diagram of AM receiver, you may find AM detector. That is a common stage where we have some parameters. This AGC works in radio receiver to maintain automatic controlling of weak and strong signal to bring it to a constant level of the output signal based on the received signal nature. That is, it maintains the same volume of the output when stations of different strength are received. If you see this stage AGC, it gets the signal after AM detector, and on the base of AM detector signal, it tries to control the previous stages. Which are previous stages? RF amplifier and IF amplifier according to need to stabilize the output. So this signal goes to the RF amplifier and same way also goes to IF amplifier so that as per requirement they can increase or decrease the amplifier gain. Result, we will get stabilized output. This AGC can improve problems like overloading and fading in receiver, and result we are getting a stabilized output. This is a very important stage in radio receiver. If we go continuously, there is another circuit called Squelch circuit. This circuit also work after AM detector stage. Usually when you are on open TV, when you switch on TV, old black and white TV and others, or AM radio with no signal, you will listen the constant hissing sound or white noise in television, which can be annoying. Just see this block diagram Squelch. Listen again. These kind of disturbance coming in television and same type of sounds are visible or listen in radio receiver. This squelch is the process of muting a channel when there is nothing on it. Note down it. Later I will ask question on it. Squelch is the process of muting a channel when there is nothing on it. The squelch circuit suppresses or mutes the noise and only turns the speaker on when the transmission comes through. It means it will respond when there is a strong signal but not respond when there is a weak or noisy signal. By this way, it helps to suppress the audio output in the absence of sufficient strong desired signal in receiver. Going next. This indicating signal is available after AM detector, and this detector signal will go to the squelch stage, and this squelch switch will work as a switch. It will open or close the action of audio pre-amplifier amplifier. It means when there is no signal or noisy signal, it will disconnect audio pre-amplifier stage so that you will not get any irritating or noisy sound. Signal to noise ratio already I have covered in previous sessions. Just a recap, signal to noise ratio is also called SN or SNR, signal to noise ratio. This one is measure of the strength of the desired signal related to background noise or undesired or unwanted signal or channel. This S to N expressed in decibel, determined by using a formula that compares the two level and return with the ratio, which shows whether the noisy level is impacting the desired signal or not. The signal to noise ratio is calculated by using a base of 10 logarithm. One thing remember, if we have values in volt, millivolt or microvolt, then the signal to noise ratio is calculated as 20 log 10 in bracket PS by Pn. Here PS is a signal in millivolt or microvolt and Pn is a signal of noise, also same way millivolt or microvolt, but same value. But when we have inputs on watts, then we are using formula as 10 log 10 PS by Pn in watts. Same way, PS means power in signal and Pn means power in noise. Variable frequency oscillator. This is the next term. An oscillator, this one already I have covered in previous session, is a electronic circuits or device that produce a oscillating electronic signal or sine wave, square wave, triangle wave, sawtooth wave, and whatever style we need it. So we are getting that kind of waves. This oscillator converts DC from a power supply to an alternating current AC signal, AC waves. This one may be fixed or depend on components. Maybe components are variable or circuit use. The stability, range, everything is dependent on use components. A VFO means variable frequency oscillator is oscillator whose frequency can be tuned. Can be tuned means we can vary on certain range or within a bandwidth or within a range. There is a one minimum and maximum range, and within that range we can tune anywhere. And this is a very important device also, and we need it everywhere. It is a necessary in any tunable radio transmitter or receiver that works by super heterodynamic principle. Super heterodynamic principle means mixing the frequency and control the frequency to which the apparatus is tuned to come to a other frequency, normally intermediate frequency or called IF frequency or some other frequency. Frequency drift or variation or changing is directly proportional to the frequency used. Low frequency VFOs drift less than high frequency VFOs. If our VFO is designed for low frequency, drifting is less, but if it is designed for high frequency, then drifting is more, and stabilizing frequency is also a question. So depend on our need, we can use different circuits for making VFO. BFO is also another type of oscillator, beat frequency oscillator, and this is very much used in radio receiver, especially in commercial and amateur radio when we are working on single side band or continuous Morse code stations. In a radio receiver, BFO used to create an audio frequency signal from transmissions to make them audible. It's mean when there is a only carrier signal in the form of tits and dash or Morse code, to make them audible we are adding BFO frequency like a local oscillator. Result different of two, we are getting a audio node. This audio node we can listen and decode the Morse code this message, and it is needed to listen SSB and Morse code. Already I have explained, just this one you remember it. This BFO stage also work along with AM detector because this give output of oscillator in AM detector to mix, and result we are getting a node. The signal from the BFO is mixed with the received signal to create a heterodyne or BF beat frequency, which is heard as a tone, audio tone in the speaker. BFO are also used to demodulate single sideband signal. Remember it, to making them intelligible by essentially restoring the carrier that was suppressed at the transmitter. Transmitter is not transmitting CW, only transmitting lower side or upper side band or single side band. Then we need to add some carrier locally, and to make add local this carrier we need a BFO to demodulate or detect SSB signals. Now coming one more oscillator, code practice oscillator. If you remember, I have explained Morse code. In this Morse code, I have explained everything, what is CPO, why it is needed, what is Morse code. But here I want to add one line. To do practice or to learn Morse code, we need a local code practice oscillator. This code practice oscillator is one of the various ways for amateur radio enthusiasts to practice the sending and receiving a Morse code using a local oscillator and Morse key. Morse code is consists of dots and dashes, or I can say long and small sound or spaces. This one already explained in previous sessions. Go through that one. And here I want to tell you, this is not the end of topic super heterodyne receiver. I am continue, but this is the time for multi-choice questions. So get ready for multi-choice question. Give me answer. You have very limited time here, so please fast, and wherever needed you can pause the video. Control is in your hand. So question 1. What is the bandwidth occupied by dual sideband signal when the modulating frequencies are 1 kHz and 10 kHz respectively? Do yourself. Choose the right answer. 18 kHz. Why 18 kHz? I want to explain you. Because Fm is equal to Fmax minus Fmin. Fmax is 10 kHz, I have already given you, and Fmin is 1 kHz, I have given that one. And difference of 2 is 9000 Hz, or I can say 9 kHz. And bandwidth is equal to 2 Fm. So 2 into 9000 means 80,000 Hz, or I can say 18 kHz. Note down it, understand it. This kind of exam can become in ASOC exam. Going next, be fast. Which amplifier is preferably used for low level modulation? Class A, AB, B, C. Time has been started. Think seriously. Choose the right answer. Class A. Just remember, in amplifier time I have already explained you, class A is amplifier is used everywhere in pre-stages or low level modulation cases, and class A, B or C is used in later part for power amplifier or current amplifier. So just going to repeat it. Low level modulation is called when the modulation takes place prior to the output element of the final stage of the amplifier at low power or pre-amplifier stages. It is preferred to use class A amplifier to avoid distortions. Efficiency is not important. Important is quality in pre-stages. Efficiency comes in later parts. If a receiver has a poor capacity of blocking adjacent channel interference, then the receiver has what? Poor selectivity, sensitivity, fidelity, or signal to noise ratio. Choose the right answer. Poor selectivity. Remember, poor selectivity is directly related to adjacent channel interference. Means he is not able to select the desired channel and reject the unwanted channels. In simple layman language, I can say selectivity is used to separate out closely lying component in terms of frequency. If the receiver has poor selectivity, then it also has a poor capacity of blocking adjacent channel interferences. Okay, got it? Going next. Squelch circuit is what? What are the functions? Choose the right answer, A, B, C or all of above. You have very limited time. All of the above. It suppressed output audio, the switch, it uses to suppress the unwanted channels and noise, and also works when there is an insufficient desired input signal. The signal is not insufficient, then it will mute it. So this squelch circuit is working as a muting circuit also. Going next. BFO stand for what? Beat frequency oscillator, broad frequency oscillator, blocking frequency oscillator or ballistic frequency oscillator. Choose the right answer. Beat frequency oscillator, don't do mistake here. BFO stand for beat frequency oscillator. The transmission of data by dots and dashes is an example of what? AM, FM, CW or discrete signal transmission. Choose the right answer. By dots and dashes or Morse code. Continuous wave transmission or CW transmission. The oscillator generates a carrier and can be switched off and on by a telegraph key to produce the dots and dashes of the international Morse code. These information transmitted in the wave is referred as continuous waves, or I can say CW transmission. CW transmission is basically a Morse code. I hope this one is clear to you. So this is an end of today's my session. I hope you like it. My super heterodyne receiver is continue in next session also, because I had to go to communication receiver also. So thank you very much for watching me today. If you really like it, kindly press the like button and subscribe to my channel. Have a nice day. See you again. Bye bye.